I want you to start by doing something for me. Just for a second, close your eyes. I want you to visualize a construction site.
Okay.
It's November, it's raining, it's cold. What do you see?
Mud. That is the first thing that comes to mind. Absolute mud.
Yeah.
Thick, cloying mud. You've got, men in high-vis jackets standing around a trench that is slowly filling with brown water.
Right. It's just miserable.
It's miserable. There's a cement mixer somewhere in the background churning away, but nobody is pouring anything because the weather is just too bad.
Of course.
It is chaotic. It is wet. And honestly, it feels archaic.
It feels like we are looking at a scene from 100 years ago, doesn't it?
It really does.
Just with better safety vests and maybe a portable toilet in the corner?
Precisely. We are building houses the same way we built them in the 19th century.
It's unbelievable when you think about it.
Brick by brick, stick by stick, completely at the mercy of the sky. If it rains, you stop. If it freezes, you stop. It's a process defined by waiting.
Now, I want you to wipe that image away. Completely delete it. Imagine a massive, pristine warehouse. It's 70 degrees inside. The air is dry. The lighting is perfect, bright, clinical LEDs.
I'm with you.
The floors are polished concrete, clean enough to eat off of. And moving down a line, almost like a car in a Toyota plant, is a house. It's being put together like a massive, precision-engineered jigsaw puzzle. The walls are being craned in with millimeter accuracy. The electrical is snapping into place. The bathrooms are being tiled.
All under a roof.
All under a roof, completely protected from the elements.
And the kicker. Once it reaches the end of that line, it's shrink-wrapped, put on a truck, driven to a plot of land, and it becomes a home in days.
Not months.
Days.
Today on the Deep Dive, we are looking at a topic that promises to revolutionize the way we live, yet is somehow one of the most misunderstood and financially brutal industries in the world.
It really is.
We are talking about modular building.
And we have to be incredibly specific right out of the gate here.
We do.
We are not talking about mobile homes. We are not talking about trailers. We are talking about high-tech, permanent structures that range from luxury single-family homes to research stations sitting on the ice in the middle of Antarctica.
Which we will absolutely get to. We have a stack of sources today that is honestly fascinating. We've got industry reports, we've got FEMA studies on hurricane damage.
Which are incredible.
And we have some pretty grim financial breakdowns of why some massive companies have lost hundreds of millions of pounds trying to crack this code.
It is a strange mix of engineering marvels and brutal economic realities.
That's a great way to put it.
It's an industry that makes so much sense on paper. It seems inevitable, but it keeps hitting walls in the real world.
So our mission today is to unpack how modular construction actually works. The nuts and bolts of the factory floor.
Right.
We're going to aggressively debunk the confusion between modular and mobile because, as it turns out, that confusion is a legal and financial nightmare for buyers.
A huge nightmare, yeah.
And we're going to look at the future, something called open source building, which sounds like something out of a cyberpunk novel.
It really does. But before we get to the sci-fi stuff, we need to ground ourselves in the definitions.
Absolutely.
Because modular is a buzzword that gets thrown around by real estate agents and tech bros alike, and half the time they mean different things.
Right. So let's strip it down. What actually is a modular building?
At its core, modular building is a method, not a style. That is the most important thing to grasp.
A method, not a style.
Okay. It is a process where a building is constructed off-site. The source material defines it as being made of repeated sections called modules.
The Lego analogy seems to come up in almost every article I read. Is that too simplistic or does it hold up?
It's actually the best way to visualize it. Think of a Lego set.
Okay.
You have these individual bricks, or in this case, entire volumetric sections of a house, that are built somewhere else. They are constructed in a factory setting.
And delivered to the site.
Then they are delivered to the site. But unlike a Lego brick, which is just plastic, these are complex 3D objects.
When you say volumetric, what does that mean practically? Are we shipping flat walls or are we shipping boxes?
That's a key distinction. There is panelized construction where you ship a flat wall, like an IKEA flat pack. But true modular, the kind we are discussing, is volumetric. You are shipping a box.
A box.
That box might be a living room, or it might be a kitchen with the cabinets already glued to the wall and the sink installed.
So you're shipping air, essentially. You're shipping the space inside the room.
You are shipping space. You are shipping a room. These modules can be placed side by side, end to end, or even stacked on top of each other.
So you can go vertical with these.
Oh, absolutely. The flexibility is actually pretty wild. You can create all sorts of configurations. It's not just put two boxes together. You can stack them 4 stories high, 5 stories high in some cases.
And once they get to the construction site, how do they stay together? I assume we aren't just using gravity.
No, gravity isn't enough. Not for a house, anyway. Once they are at the site, they are joined together using intermodule connections.
That's just engineering speak for.
Big bolts.
Okay.
Plates. Heavy-duty fasteners that pull these independent boxes together so tightly that they act as one unified structure.
So it becomes monolithic.
Yes. Once those connections are made and the drywall is patched over the seam, you really can't tell that it was built in pieces. It acts as one single structural unit.
I want to go back to the factory floor, because this is where the efficiency argument really lives or dies. The sources keep mentioning lean manufacturing. Now, I went to business school, so I know that term usually applies to building Toyotas. What does it mean for building a bathroom?
It means applying the exact same principles used to build a Corolla to building your master suite.
That's a heck of a mental image.
It is. But think about a traditional job site again. It's linear and it's messy. You have tradesmen tripping over each other. The electrician can't start until the framer is done. But the framer is waiting on lumber that's stuck in traffic. Then the plumber shows up, but the floor isn't ready, so he leaves for another job.
And meanwhile, you're paying interest on the construction loan. Every single day of delay costs money.
Exactly. It's inefficiency baked into the system. In the factory, it's an assembly line.
Controlled.
It's a controlled environment. The materials are staged right there. The tools are hanging from the ceiling on pneumatic lines. You don't have workers driving to a site, setting up their radio, unpacking their truck, doing 3 hours of work, tearing down, and driving home.
That makes so much sense.
It's a completely different workflow.
And because of that control, the sources highlight a statistic that I actually had to read twice. They claim these buildings are often 60 to 90% completed before they ever leave the factory.
It sounds incredibly high, but that's the goal.
That seems almost impossible.
Well, think about what complete means.
So when you say 90% complete, paint me a picture. If I walked into that module in the factory just before they loaded onto the truck, what would I see?
You'd see painted walls. You'd see the power outlets wired and tested. You could literally plug a lamp in.
No way.
The water and sewage lines are installed in the walls. The air conditioning ductwork is in.
So all the guts of the house are already there.
All the guts. And even the interior finishes. The granite countertops, the kitchen cabinets, the bathroom tile, it's all installed at the factory.
So when it arrives at the site, you aren't doing drywall mudding. You aren't tiling.
Ideally, no. You are basically just hooking up the utilities, connecting the wiring harness from Module A to Module B, connecting the pipes to the main line, and patching the mate line where the boxes touch.
It's almost plug and play.
It really is, like giant inhabitable Lego bricks.
That explains the speed. The sources say the construction of a specific module can take as little as 10 days.
In the factory, yes. The throughput is incredible.
Yeah.
Usually the whole process from order to delivery is 1 to 3 months, but the actual time that specific house spends on the assembly line is incredibly fast.
But the real magic, and this is the aha moment for the logistics nerds out there, is something called parallel processing.
Yes, this is the key.
Okay, break that down. This is distinct from just building fast.
Yes. In traditional construction, everything is sequential. It is a waterfall. You cannot build the frame until the foundation is poured and cured.
Step 1, then step 2, then step 3.
Right. You can't pour the foundation until you've dug the hole and graded the land. It's a long, slow chain of dependencies.
Right. And if step 1 is delayed by rain, step 2 is pushed back, and step 3, the guy installing the windows is now fully booked on another job, so you wait 3 weeks.
Exactly. It's a cascade of delays.
Yeah.
But with modular, you have parallel timelines.
How so?
While the guys on the site are digging the hole and pouring the foundation,
Okay.
the factory's already building the house.
So the house is being built at the exact same time the land is being prepped.
Yes. They are happening simultaneously. So by the time the foundation is dry and ready to accept a load, the house shows up on a truck, ready to be craned into place.
That is how you shave months off a project.
That's it. You are compressing the schedule by doing 2 major things at once.
And once it's on site, how long does the actual assembly take? I've seen time-lapse videos of this, and it looks fake.
It does look like CGI. The source says placement of the modules can take just hours or a few days.
Hours.
Yeah. You literally watch a building appear over a weekend, Neighbors go to work on Friday, come back on Monday, and there is a 2-story house standing there. It feels like magic.
That is incredible, but I have to play devil's advocate here.
Please do.
I feel like there's a massive stigma attached to the word prefab. People hear that and they think cheap plastic. They think flimsy.
That is a holdover from the 1970s, and honestly, even earlier post-war temporary housing.
So it's an outdated perception.
It's completely outdated. The sources are very clear on this. This is permanent modular construction, or PMC.
So these aren't temporary structures.
Not at all. They are intended to remain in one location for the duration of their useful life, just like a traditional home.
And they are built with standard materials.
Yes.
The same stuff a normal house is made of. We aren't talking about some composite space-age plastic.
No. Standard 2x4 or 2x6 wood framing. Steel. Concrete. In fact, steel is becoming really common because it's moldable for cool designs.
So you can get more creative with it.
Exactly. And concrete is used for fire resistance and acoustic insulation between modules. If you cut into the wall of a high-end modular home, you'd see the exact same studs and insulation you'd see in a custom-built home.
Okay, so we've got a house built in a factory made of steel and concrete, finished in record time. But here's a question I think everyone asks when they hear built in a factory and shipped on a truck.
I know where this is going.
Doesn't moving a house break it?
It's a valid fear. You imagine a house rattling down the highway, cracks forming in the drywall, windows popping out, tiles shattering.
I mean, I get nervous moving a bookshelf in a U-Haul. Moving a whole kitchen with granite countertops seems like a recipe for disaster.
But here is where it gets really interesting, and it's kind of counterintuitive.
Okay.
The expert consensus and the engineering data shows that the transport process actually forces modular buildings to be stronger than site-built homes.
Stronger. How does putting it through a magnitude 6 earthquake on a highway make it stronger?
Because it has to survive that earthquake. Think about the forces at play.
Right.
A module has to be lifted by a crane that puts massive tension on the frame. Then it's placed on a truck. Then it's driven at 60 miles per hour down a highway.
And you're dealing with potholes.
It's enduring potholes, wind resistance, which is essentially hurricane force winds if you're driving into a headwind and constant vibration. And then it's lifted by a crane again.
It's like a structural torture test before anyone even moves in.
Precisely. A traditional house never has to survive that.
Yeah.
It is built on the ground and it stays on the ground. It never experiences 2G forces from a pothole.
So they have to over-engineer it just for the delivery.
Because modular homes have to survive that journey, they are over-engineered. The sources note some really specific durability specs.
Like what? Give me the details.
For example, they typically use screws instead of nails for the drywall and framing connections.
Why screws? What's the difference?
Nails rely on friction. With enough vibration, like a 500-mile truck, ride nails can back out. We call it nail pop.
I've seen that in older houses.
Exactly. Screws hold tight. They don't back out under vibration.
Okay, that makes sense. Simple but effective.
They also often add glue to the joints for extra rigidity. It's a glue and screw method. And here is a stat from the text. They typically use 8 to 10% more lumber than conventional housing.
8 to 10% more.
Yeah.
Just for the trip.
Just to bulk it up for the road trip.
Exactly.
They're adding extra framing, extra bracing, strapping the walls differently just to maintain structural integrity during transport.
So by the time it lands on your foundation, you have a house that is essentially a tank.
In a way, yes.
It was built to survive a road trip, which means it is incredibly robust once it's sitting still.
That's the logic. And it holds up.
That's a fascinating inversion. The vulnerability of transport creates the strength of the final product. It's like buying a laptop that's military-grade drop-tested versus one that's just meant to sit on a desk.
That's a great analogy, and we actually have real-world data to back this up. It's not just theoretical engineering talk.
Okay.
There was a fascinating revelation in the source material regarding FEMA.
This was the study after Hurricane Andrew, right?
Yes. Hurricane Andrew devastated Dade County, Florida in 1992. It was a Category 5 storm. Absolute destruction.
I remember the footage. It was apocalyptic.
It was. FEMA went in afterward to assess the damage, essentially a forensic audit of the housing stock to see what failed and what survived.
And what did they find? Because the perception is that prefab stuff flies away in a stiff breeze.
The opposite. They concluded that modular and masonry homes fared better than other types of construction.
Better than the site-built wood frame houses.
Yes. The reports specifically noted that the modular units held up incredibly well.
Wow.
And it comes back to that over-engineering. If you build a house to survive a 60-mile-per-hour highway drive with wind resistance, you've inadvertently built a house that is pretty good at surviving high winds.
That is a massive validation. I mean, Hurricane Andrew is no joke. If it can stand up to that, it can stand up to a standard thunderstorm.
Absolutely. And it's not just the U.S. The sources mention European standards, specifically the CE marking.
What is that exactly? I've seen the CE logo on electronics. My toaster has one.
Okay.
But on a house.
In Europe, the CE mark acts as a guarantee of mechanical resistance and strength. But what's fascinating is the level of traceability.
Traceability.
The source says that because it's a factory process, every batch of raw material is recorded.
So they know exactly which batch of steel went into your living room wall.
Yes. Suppliers are certified, raw materials are tracked by batch, and assembly quality is managed step by step.
It's like a car's VIN number.
That's a perfect comparison. When a unit is finished, it gets a unique ID and stamp. It guarantees resistance against wind and earthquakes because there is a digital paper trail for every bolt and beam.
You definitely don't get that with a traditional builder. I mean, half the time, you don't know where they bought the lumber or if they followed the specs perfectly.
Right. In a factory, you have quality control inspectors checking every stage. On a job site, the inspector comes by maybe once or twice for key milestones, foundation, framing, final.
But they aren't watching the glue dry.
They are not. They aren't checking the torque on every screw. In a factory, that is part of the workflow.
So we've established they are strong, we've established they are fast, but we keep dancing around this elephant in the room, the mobile home confusion.
This is the identity crisis. It is the bane of the modular industry's existence.
It really is. I feel like if you tell someone, I live in a modular home, they immediately picture a trailer park. They picture wheels.
And the industry hates that. It's a major pain point. But the distinction is actually legal and structural. It's not just marketing fluff.
It's not just rebranding.
No, it's not just a rebranding exercise. They are fundamentally different things.
So let's clear the confusion once and for all. What is the actual difference between a modular home and a mobile or manufactured home?
It starts with the building code. This is the boring but essential part.
A boring but important part.
Exactly. Modular homes are built to local or state building codes, usually the IBC, the International Building Code, or the IRC, the International Residential Code.
Okay, so what does that mean in practice?
It means they are treated exactly the same as a house built on-site. If your town requires a certain thickness of insulation or a specific type of roof truss to handle snow load or a specific type of wiring, the modular home has to meet that standard.
So it's legally a house, period.
And mobile homes.
Mobile homes or manufactured homes are built to a federal code established by HUD, the Department of Housing and Urban Development, a national standard.
A completely different set of rules. The HUD code overrides local codes. It allows for different standards regarding frame construction, insulation, and fire safety.
So modular equals local code, mobile equals federal code.
Correct. But the physical difference is even easier to spot.
Oh, great.
It's all about the foundation versus the chassis.
The chassis, like on a car.
Yes. A mobile home, or manufactured home, has an integral steel chassis with axles. It is built on wheels.
It's part of the structure.
Even if you take the wheels off, that steel frame is part of the floor structure. It's designed to be potentially moved again.
And a modular home.
A modular home is placed on a permanent foundation or a basement. Once it's there, it's there.
It becomes part of the land.
But there is no chassis. The floor joists sit directly on the foundation walls. You can't just hook it up to a truck and drive away. It becomes real estate.
Okay, that's a clear distinction. But what if I'm looking at a house and I can't see the foundation? Maybe there's skirting or landscaping. Is there a way to tell just by looking?
There is a listener tip here. We call it the tag test.
Ooh, I love a good hack. How does the tag test work?
If you are looking at a mobile or manufactured home, there will be a small metal tag on the outside of each section.
On the outside?
On the siding, yeah. It's usually red or silver, riveted on. You can't miss it if you look for it.
Okay, external tag equals mobile.
Right. A modular home has no external tag.
None at all.
Instead, it has what's called a data plate inside the house.
Where do I find that?
Usually under the kitchen sink, or sometimes on the back of the master bedroom closet door, or near the electrical panel.
And what's on it?
It looks like a spec sheet. It lists the manufacturer, the inspection agency, the appliance info, the design loads like snow load and wind load, and the manufacturer date. So if you're house hunting and you're unsure, look under the sink.
That is super useful. Now let's talk money. Because usually banks are pretty picky about what they finance. Do they treat these differently?
This is where the code distinction matters most to your wallet. Because modular homes are built to local codes and are permanent, banks finance them with standard construction loans and traditional mortgages, the same as a site-built home.
So you can get a regular 30-year fixed mortgage with normal interest rates.
Exactly. Mobile homes, on the other hand, often require special lenders
Why is that?
because they are sometimes classified as chattel or personal property, like a car or a boat, rather than real estate.
So it's not a real estate loan, it's a personal property loan.
Right. Unless they're permanently affixed to land and you go through a legal process to retire the title, the interest rates on those chattel loans are usually much higher.
What about resale value? Does a modular home resell for less?
In the U.S., the valuation differences are often negligible. Appraisers look at it as a house.
They don't care how it was built.
They look at the square footage, the finishes, the comps in the neighborhood. If you can't tell the difference just by walking through it, the market generally doesn't care.
But that's not the case everywhere.
However, the sources do note that in the UK and Australia, there is still some resistance.
Cultural resistance.
Yes, and institutional. Some lenders and zoning boards are still skeptical about value retention. There is a worry that system-built homes might degrade differently than brick and mortar.
So there's a trust gap.
A bit of one, but as the quality improves and as more of them are built, that gap is closing.
Speaking of the UK, let's pivot to the economics of the industry itself.
Okay.
Because for all the benefits we've just listed, speed, strength, quality, efficiency, it seems like a no-brainer business. If I were an investor, I'd be throwing money at this.
You think so?
But the sources paint a pretty bloody picture of the industry in the UK recently.
It's a paradox. The product is great, but the business model is brutal. We have a perfect case study from the UK in the 2010s and 2020s that serves as a cautionary tale.
Set the scene for us. Why the UK?
The UK has a massive housing shortage. They simply do not build enough homes.
A chronic problem.
A chronic, well-known problem. The government knows this. So, via an agency called Homes England, they decided to invest heavily in modular housing initiatives. They saw it as the silver bullet.
Fast, scalable, modern.
All of the above.
Sounds like a solid plan. Government backing, huge demand. What went wrong?
Well, despite huge investments, we saw a spectacular crash of several major players. The sources mention companies like Ilk Homes and L&G Modular Homes.
Let's talk about Ilk Homes. What happened there?
Ilk Homes was a darling of the sector. They received over £60 million in government funding.
60 billion.
And raised another £100 million privately. That is a war chest. They had the robots, they had the press releases, they were the future.
That's huge money.
And yet they went into administration, which is the UK equivalent of bankruptcy protection, in June 2023. And the debt. They owed £320 million.
320 million in debt. How do you burn through that much cash selling houses?
And that's not even the biggest one. Then you look at L&G Modular Homes. Legal & General is a massive insurance and pension firm.
These aren't amateurs. They have deep pockets.
Exactly. They built a massive 550,000 square foot factory near Silby.
Over 500,000 square feet? That's enormous.
It is, like, multiple football fields, enormous. But they lost over £100 million before they even started earning significant revenue.
100 million before they really even got started.
Yes. By the time they halted production in 2023, the total losses hit £295 million.
Okay, expert analysis time. Why? If the houses are so good, why are the companies going bust? Is it just bad management, or is the model flawed?
It comes down to upfront production investment versus the reality of the construction cycle.
The CapEx trap.
The cost of the factory. Precisely. Think about a traditional builder. What do they need to start a project?
A truck, some tools, a few good guys.
They buy a plot of land, they hire some subcontractors, their upfront costs are relatively low. They get paid as they build. If the market slows down, they just stop building and lay off the subcontractors. Their costs are variable.
Right. They don't need to build a factory first. They don't have overhead when they are building.
Exactly. But a modular company has to build the factory, buy the robots, hire the staff, pay for the electricity, and set up the supply chain before they sell a single house.
So they are in a deep hole from day one.
A very deep hole. And to get out of it, they need volume. They need to be pumping out thousands of homes to cover those fixed costs.
The factory has to run at capacity.
It has to. If they can't book revenue fast enough, the overhead eats them alive.
And the sources mention planning delays as a culprit, too. This seems to be the specific bottleneck in the UK.
That's the other side of the coin. You have this factory that can build 1,000 homes a year, but you need land to put them on. And in the UK, the planning permission system, getting the permits to build, is notoriously slow. L&G specifically blamed local planning delays. They had the factory ready to run, they had the homes designed, but they had nowhere to put them.
So you have a factory bringing cash every single day, waiting for a permit to pour a foundation. That's a nightmare.
It's a tragic misalignment of speed. The factory is fast, the bureaucracy is slow, the factory assumes a steady flow, but the real estate market is stop and go.
But it's not failing everywhere, right? The sources mention Japan.
Japan is a fascinating contrast. Modular is increasingly common in Japanese urban areas. Companies like Sekisui House are massive.
Why does it work there? What's different?
A few reasons. One, the density. Japanese cities are tight. Modular allows for a level of compactness and precision that's hard to do on site.
So it's a better fit for the urban environment.
For sure. Two, earthquakes. As we mentioned, these structures are rigid and strong. Ease of repair or replacement after a quake is a big selling point.
And I assume the cultural perception of manufactured is different there.
Very different. Japan respects precision manufacturing. They don't see factory made as cheap. They see it as high quality. They trust the robot more than the craftsman in some ways.
That's a really important distinction. It's about branding as much as engineering. In the West, we romanticize the hand-built home, even if hand-built means built in the rain by a guy who is tired.
Absolutely. We value the bespoke illusion, even if it's structurally inferior.
So we've covered the homes, the business, the failures. Now I want to go to the extremes.
Okay.
Because modular isn't just about suburban housing. The sources mention some pretty wild use cases where traditional building is literally impossible.
It doesn't get more extreme than Antarctica.
The Halley the Sixth Research Station.
Yeah.
This thing looks like an AT-AT Walker from Star Wars.
It really does. The British Antarctic Survey needed a base on the Brunt ice shelf. Now think about the logistics.
Right.
You cannot send a crew of bricklayers to Antarctica. It's freezing, it's remote, and here is the kicker. The ice is constantly moving. It flows toward the sea.
So if you build a normal building, it eventually falls into the ocean.
Or gets buried in snow. So modular was the only reasonable option. They built accommodation pods. Basically, high-tech modules.
On stilts?
On hydraulic legs fitted with giant skis. They shipped them there and assembled them like a space station.
And the hydraulic legs allow them to move the station if the ice cracks.
Exactly. If the ice shelf develops a fissure, they can hook up tractors to the pods and tow the entire research station to a safer location. It is the ultimate mobile modular building.
That is incredible engineering.
Yeah.
It shows that when constraints are high, modular wins.
It has to. And on the flip side, the sources talk about disaster relief. This is less sci-fi, but arguably more important.
Speed is the factor here, right?
Yes. When a disaster strikes like a tsunami or an earthquake, infrastructure is wiped out, you need toilets, showers, clinics, and housing now.
There's no time to waste.
You can't wait 6 months for a build. Modular units, often adapted from shipping container concepts or specialized flat packs, can be trucked in or flown in to provide immediate sanitation and shelter.
It's literally saving lives by being fast.
It is. It's utilitarian but essential. It turns shelter into a product you can ship.
Okay, let's pivot to the future. This is the part of the outline that really caught my eye. Open modular building and the open source movement.
This is where it gets really interesting.
When I think open source, I think of software, Linux, Wikipedia. How do you open source a house?
This is a really exciting theoretical shift. It's often called P2P construction peer-to-peer.
Peer-to-peer. How does it work?
Imagine if architectural plans were like software code. Currently, architecture is very proprietary.
You hire an architect, they own the design.
Right. You pay an architect, they draw plans, you own that specific set. But open source changes that. Instead of every architect hoarding their designs, they share them online. A community of designers works together to perfect a module.
So I could go online and download a design for a bedroom module.
Yes. The concept is open structures. Just as software has shared libraries that anyone can use, building is moving towards shared designs and tools.
You download the file. What then?
You download the file, and instead of sending it to a printer for paper, you send it to a CNC machine, a computer-controlled cutter that cuts sheets of plywood into puzzle pieces.
That sounds incredibly democratic.
That's the word. Democratization. It allows communities to share plans and use low-cost materials. The source mentions using things like plywood or even 3D printing.
So you don't need a massive LNG factory.
Yeah.
You could theoretically do this in a local makerspace.
That's the dream. It empowers people to reconfigure their public sphere. The source compares it to pre-industrial vernacular architecture.
Unpack that phrase. That sounds like academic jargon.
It basically means how we used to build before professionals took over.
Okay.
Before professional architects, communities built their own homes using local styles and methods. Everyone in the village knew how to build a barn. You used local wood, local stone.
It was common knowledge.
It was. This is a high-tech return to that. It's using modern tech to let communities build for themselves again rather than relying on a giant developer.
And I imagine this links to sustainability.
Hugely. It's green building meets commons-based activity. If you can 3D print a module locally using recycled materials, your carbon footprint is a fraction of shipping a steel box from a factory 500 miles away.
You eliminate the transport cost.
Which, as we discussed, is the hardest part to modular.
It feels like we are on the cusp of a major shift. We have the big tech version, massive factories churning out precision homes like Toyota's, and the grassroots version.
Yeah.
People downloading plans and printing them locally.
And both are driven by the same realization. The old way of building brick by brick in the mud doesn't make sense anymore.
It's broken.
It's too slow, too expensive, and too wasteful.
So let's wrap this up. We've covered a lot of ground, from the factory floor to the Antarctic ice shelf, from the financial ruin of UK startups to the open source future.
We have. It's a huge topic.
If we summarize the current state of modular building, it seems like a technology that has proven itself technically. It works, it's strong, it's fast, but is struggling to find its business footing in some places.
That's a fair assessment. It is faster, it is potentially stronger, it is technically sophisticated, but it is fighting two wars.
Two wars.
One against market perception, the mobile home confusion, and one against the brutal economics of factory setup costs.
But the trajectory seems clear.
I think so. The final takeaway for me is that we are moving toward a world where a house is a product, like a car.
Traceable by serial number.
Exactly. Manufactured to spec, quality controlled, and delivered complete. The idea of a custom stick-built home might eventually become a luxury oddity like a hand-built car is today.
That is a wild thought. Most people drive Toyotas, not hand-built Rolls-Royces. Maybe we'll all be living in Toyotas soon.
And we'll be warmer, safer, and build them faster because of it.
I want to leave the listener with a provocative thought based on that open source discussion. We are seeing 3D printing get bigger and cheaper. We are seeing designs go online.
Where is this going?
If open source modularity takes off, will we see a future where you download your house design and print it locally, bypassing the traditional construction industry entirely? Could Amazon, or just a local library, become your home builder?
It sounds impossible now. But 20 years ago, so did printing a kidney or carrying a supercomputer in your pocket. I wouldn't bet against it.
Something to mull over the next time you see a construction site stuck in the mud. Thanks for diving deep with us.
It was a pleasure.
See you next time.